Let's talk about OSI model. Hello and welcome to PepTech Talks. Keep liking and subscribing to the channel to get more new upcoming videos. If you are here, that means you are ready to step into the world of cybersecurity and things get serious from here on. I am serious, but I am not boring when it comes to cybersecurity. We are going to have two parts for this video presentation. The reason being, OSI is a big topic, and I would not expect you to sit for 30 minutes straight and go through this video without a coffee, tea, or a smoke break. So, enjoy the first part with an introduction to OSI model. So the part 1 would cover in this video, we will take a detailed look at the OSI model, which is the foundation of network communication. Understanding the OSI model is critical for anyone who wants to learn about network security. In this first part, we will cover the introduction, layers, and TCP/IP to OSI model comparison. We will discuss the functions of each layer very briefly, the protocols used, and common security risks associated with these layers in the next part. Our presentation would contain introduction to OSI model, overview of the OSI model, TCP/IP model versus the OSI model, physical layer, data link layer, network layer, transport layer, session layer, presentation layer, application layer, and a summary. A scenario for OSI model implementation could involve setting up a secure web application for online banking. At the physical layer, network cables or wireless communication channels would be used to transmit data between the user's device and the bank's server. The cable and wireless communication channel would need to be secured and protected from physical attack and unauthorized access. At the data link layer, the data would be encapsulated into frames and transmitted over the physical layer. Measures would need to be taken to prevent unauthorized access to the frames and ensure the integrity of the data. At the network layer, the bankers' servers would need to use protocols such as IP, Internet Protocol, and routing protocols to send and receive data over the Internet. The bank's servers would need to use firewall and intrusion detection systems to protect against unauthorized access and prevent denial of service attacks. At the transport layer, the bank's servers would need to use a secure protocol such as SSL or TLS to encrypt the data transmitted between the user's device and the bank's servers. This would help to ensure that the data is not intercepted or modified during transmission. At the session layer, the bank servers would need to use authentication mechanisms to ensure that only authorized users can access the online banking application. The session layer would also be responsible for managing the session between the user's device and the bank's servers, ensuring that the user's data remains secure throughout the session. At the presentation layer, the bank servers would need to use encryption and decryption mechanisms to ensure that the data is presented in a format that is understandable by the user's device while also maintaining the confidentiality and integrity of the data. At the application layer, the bank server would need to use secure application level protocols such as HTTPS to provide a secure communication channel between the user's device and the bank server. The application layer would also need to implement measures to prevent common web application attacks such as SQL injection and cross site scripting, commonly referred to in short as XSS. Overall, implementing the OSI model in this scenario would help to ensure the security and integrity of the online banking application, protecting both bank and its customers from potential security breaches and data theft. The OSI model is an important concept in modern networking. It provides a standard way of understanding how communication occurs in a network and is used to promote interoperability between different systems. By understanding the different layers of the OSI model and their responsibilities, one can better design and manage their networks. This model is an important concept in cybersecurity or network security specifically targeted, as it provides a framework for understanding the different layers of network communication and how data is transmitted over the network. By understanding the model, cybersecurity professionals can better identify and mitigate threats to network security. Each layer of the OSI model has its own vulnerabilities and potential attack vectors, which can be exploited by attackers to gain unauthorized access to a network, intercept sensitive data, or cause damage to the network infrastructure. For example, attack on a physical layer can involve physical theft or damage to network equipment, while attack on the data link layer can involve MAC address spoofing, VLAN hopping, or denial of service attacks. Attacks on the network layer can involve IP address spoofing, routing attacks, or network reconnaissance, while attacks on the transport layer can involve TCP/IP hijacking, SYN flooding, or port scanning. By understanding the different layers of the OSI model and their associated threats, cybersecurity professionals can better design and implement security measures to protect their networks. This can involve measures such as firewalls, IDS or intrusion detection systems, encryption, access control, and monitoring tools, among others. Overall, the OSI model provides an important foundation for understanding network security and is a crucial concept for cybersecurity professionals to master in order to protect their network from evolving threats. Let's have a quick overview of the OSI model. The OSI model is a conceptual framework used to describe how data is transmitted over a network. It consists of 7 layers, each of which has a specific role in the process of transmitting data. Here's an overview of the model with an example to help illustrate how it works. Physical layer. This layer deals with the physical aspect of the network communications, such as cables, connectors, and other hardware used to transmit data. An example of this layered device is a network interface card or a NIC card. Data link layer. This layer is responsible for establishing and maintaining a link between two devices on the same network. It also handles error detection and correction to ensure data integrity. An example of a data link layer device is a switch. Network layer. This layer is responsible for routing data between networks. It provides logical addressing and routing services and is responsible for packet forwarding and congestion control. An example of a network layer device is a router. Transport layer. This layer is responsible for providing reliable data transfer between end to end nodes. It ensures that data is transmitted without errors and in the correct order. An example of a transport layer protocol is TCP or Transmission Control Protocol. Session layer. This layer is responsible for establishing, managing, and terminating sessions. My bad. Between applications. It provides synchronization, checkpointing, and recovery services and ensure that the data is transmitted securely. Example of a session layer protocol is SSL or Secure Sockets Layer. Presentation layer. This layer is responsible for data representation and encryption. It provides services such as data compression, encryption, and decryption, and is responsible for translating data formats between different systems. For example, uh, an example of the presentation layer protocol is MIME, MIME, and it is referred to as Multipurpose Internet Mail Extension. Application layer. This layer is responsible for providing network services to applications. It includes protocols such as HTTP or Hypertext Transfer Protocol, SMTP or Simple Mail Transfer Protocol, and FTP as File Transfer Protocol. These are responsible for providing services such as file transfer, email, web browsing. Overall, the OSI model, provides a clear and structured way to understand how data is transmitted over a network. By breaking down the process into separate layers, it's easier to understand how each layer contributes to the overall process of network communication. This can be helpful when troubleshooting network issues, as it allows you to pinpoint the layer where the problem is occurring. Additionally, understanding this model can help network administrators and security professionals design and implement more secure networks by identifying potential vulnerabilities at each layer. The open system interconnection model and the transmission control protocol or the internet protocol model are two different some conceptual models used to describe the communication protocols used in computer networks. The main differences are number of layers. The OSI model has 7 while the TCP/IP has 4. The OSI model was developed before the TCP/IP model and is more detailed and comprehensive, while the TCP/IP model is simpler and more practical. Protocol suites. The OSI model defines a theoretical protocol suite that is not used in practice, while TCP/IP model defines the actual protocol suite used on the internet. Naming of the layers. The OSI model layers are named from layer 1 to layer 7, that is physical layer to application layer, while the TCP/IP model are named from layer 1, that is network interface layer, to transport layer, that is layer 4. Functionality of layers. The OSI model separates the functions of each layer strictly, while the TCP/IP model combines some of the functions of the OSI model layers into fewer layers. For example, the TCP/IP model combines the OSI model's physical and data link layers into the network interface layer. Flexibility. The OSI model is more flexible than the TCP/IP model because it allows for the creation of new protocols at each layer, while the TCP/IP model has a fixed set of protocols. If you liked the video, please click on the like button and leave me a thumbs up. And also, please kindly subscribe to the channel. Thank you.